Good day, everyone. Good day, everyone. I am Samantha Feitan, and I am here to present a type of clustering called hierarchical clustering. So, what is hierarchical clustering? According to IBM, hierarchical clustering is an unsupervised machine learning algorithm that groups data into a tree of nested clusters. So, I want you to imagine that you have a dataset of animals, and we have a tree for that animals. At the top of the tree is animal, and under that we have branches uh, of clusters. So one branch is uh, one cluster, and one one of it is mammals, another branch for birds, and we have another branch for fish. And under mammals, we can imagine that we have um, dogs, we have cats, and under dogs and cats, we have species of dogs, and we have for the cats, we have species of cats, and for birds, we have birds that can fly, birds that cannot fly, and basically, I want you to think of it as the further down you go into the tree, the more specific the cluster is going to get. And we have two main types of hierarchical clustering. We have agglomerative and divisive. Agglomerative is for bottom to top. Bottom to top. Okay? So, for example, we start from Shih Tzu, and then we go to dogs, we go to mammals, and we go to animals. So bottom to top, to bottom to top, specific to general. And for divisive, it is opposite. Okay, we go from top to bottom, so from general to specific. Animals, mammals, and then we go to dogs, and we go to Shih Tzu. And yeah, hierarchical cluster analysis helps find patterns and connections in datasets. Results are presented in the dendrogram diagram showing the distance between relationships of clusters. And this is what a dendrogram looks like. So to understand this type of clustering more, let's go deeper into our code. So first, we have imported our CSV file called mall customers, and then we pre-process the data, and we selected the features of age, annual income, and spending score. We excluded the gender because we want continuous values, and then we scaled that features to get a more balanced data set. And then here, to determine the optimal number of clusters, we are going to draw a dendrogram. This is what I showed you before over here. This is what our dendrogram looks like in this dataset. And to get the number of optimal clusters, to get the optimal number of clusters, we are going to look at where the vertical line is getting big. Okay, so in this case, between 5 to 12.5, I see that the vertical line is getting bigger. And this is generally where you want to draw a vertical line, a horizontal line, I mean. So I want you to think, I want you to imagine that I draw a vertical line at 7.5 over here. And then to get the number of clusters, we count the number of vertical lines that our horizontal line came across. Okay, so we have one vertical line, so we have one cluster, and then another one. So we have two clusters, three clusters, four clusters, five clusters, and six clusters. So that's from analyzing that dendrogram, it is determined that 6 might be the best number of clusters because there's not really a general or a specific rule on where you draw that horizontal line, but basically you want it you want to draw the line where a vertical line is getting bigger. Okay, and over here we have applied we apply the hierarchical clustering, and we use the agglomerative clustering. This one, oh, this one, just the bottom to top one, and we give them the number of clusters that from our dendrogram, from analyzing the dendrogram, and the metric of Euclidean. Euclidean is just the equation that we use to get the distance of a data point from another data point. And word, we use the word for linkage because it is said that it is the least affected for outliers and noise. And here we just added another feature in our data frame called cluster to see what cluster the customer is going to belong to. And here I just visualize a scatter plot to see the centroids of the clusters that we have that we got. So we have 6 clusters, 0, 1, 1, 2, 3, 4, 5, 6, and this is what we end up with. And yeah, that's basically what hierarchical clustering is. It's just it's a dendrogram. Yeah. Thank you so much for listening, and thank you.